Good morning.
Good morning.
So I'm invited here to wake you all up this morning. So hopefully most of you will still be a friend of mine after this talk. I held a similar talk, a little bit shorter, in front of 60 CMOs a few weeks ago. And one of them, a CMO of a company of 1 billion revenue, 20% growth every year, he came to me and said, you know what, we do zero market research. But I heard your talk, and now I believe we should do it because now with Causal AI, we can gain the insight we need. And this was this was a personal aha moment to hear that. They are still, there's a big skepticism, not in our bubble, but among marketers for market research. So we have a growing need for insights. Yeah? And that's a little bit a metaphor of how the world looks like. Yeah? We have a growing need for insights, but we're starving in a lake of information. Yeah? And the metaphor is too often we sell salty water. We sell information, but what companies need is something else. Okay, so from an outside view, we have a problem. Yeah? The market research industry has a problem. But I think we can do better. So I would like to talk today what causal thinking and causal AI can bring to you. But first, before I explain how it works, because when I do that, you are kind of bored because it's very technical. I first start showing you that it is a big deal. I will show you the applications of the technology. And only then, so 30 minutes left, then I will talk about how it works and what the technology needs to solve. And also, we talk about how to get started, how you can get started tomorrow. That's the agenda. So let's start. What's in for you? What is the thing? So first off, Causal AI is a group. Yeah, it's like Gen AI. Yeah, Gen AI is not a software. It's a term, right? And Gen AI is in the peak of the Gartner hype cycle. But luckily, Causal AI is in it too. Yeah? So it is already recognized as a group of technology that will change business and will drive huge impact. Yeah? So we are expected in 2 to 5 years to arrive at the peak and the peak of the hype. So it's already there, and there are different software vendors pushing for that. But is it useful? First off, it has been invented yesterday, right? So we are applying it since 10 years and more. I have presented work with Causal AI with Intel, Sonos, Microsoft at ASMR conferences. We not always called it this way because people didn't know the term. But it is around since a while and it's evolving. And this is my favorite success case. It started over 10 years ago where we started to work with T-Mobile USA. And for Christmas, I got this email from David Feig. You can't imagine how impactful your work has been. It informs high-level strategies and so forth. So I was over the moon. And I wasn't expecting it because we just did our analysis, right? So, but you don't know really how impactful it is. And it was impactful. It was so impactful that it was the ground for the strategy the company was doing, and that finally, 2 years ago, I met the CEO of T-Mobile, and he presented that because of these moves, the Deutsche Telekom is now the #1 telecom company in the world because of the success of T-Mobile USA. How did we do it? What did Causal AI do? So basically it was 2013 when the company was changing basically everything. They changed the positioning, they eliminated contract terms, introduced a flat price fee. Everything was new. Yeah? Flat pricing was not used in the industry at that time. So and still they gave an iPhone on top. So customer loved it. They grew, but the company didn't know why. Was it the iPhone? Was it the contract term? Was it the marketing? What was it? And the answer was so important because everything they did could be copied by the competition. So when we took their brand tracking data and found something which were the key insight. It was that although their product changes and so forth were not the key direct cause for people to consider the brand. It was an indirect cause. It was the reason why people believed T-Mobile is the Robin Hood of the industry. And then the team said, we just need to invent little product features that prove that we are the Robin Hood of the industry. So they introduced then global roaming for free and all those things. So they call it the carrier strategy, but it was all based on this insight that this Robin Hood positioning is key, and we can drive that and prove that with certain innovative product features. And the rest of the success is history. They were loss-making and are hugely growing, bought Sprint and are now even with AT&T. Another case study, worked with Sonos. Sonos was at a declining NPS, and so their owners were kind of declining, and they were speculating what's the reason? Yeah? Is it maybe the customer base is changing or whatever? So, and we did use Causal AI on their ownership studies, the ownership surveys. So basically, they ask every owner NPS question and open-end. And the insight we drew changed their way of investing. Before that, they invested in sound quality, and now they invested in the streaming software. And 6 months later, of implementing the NPS improved by six points, which is a huge impact. So what did we do? We basically used this NPS data where you have open ends, categorized the open ends with text AI, but that's not enough. When you look how often people saying the bubble on the top is sounds great. So people often say, if you ask, why did you read this way? Sounds great. The sound is good. But actually, and that is what we see in every study, the frequency of mentioning of the topic is actually not correlating with the impact the category has. Instead, there were other topics, especially reliability of the performance. So if the streaming stops, that's annoying, right? So, and when people are really complimenting, say, hey, that's greater reliability, this is the key to drive loyalty and recommendation. And it's not so often mentioned because they have some problems, right? So and that's where the company shifted investments. Again, what Causal AI found is the driver, the impact of the things people are saying. So something which you cannot see directly in the data. Last impactful example is from, we work with Mintel. Mintel, London-based, right? They collect new product launches. So basically, every product which is launched in supermarkets, they have mystery shoppers finding them, assessing them, sending it into the headquarters, and they collect every kind of data about this new product launch, right? So we took a data set with all those product launches for the US of 1 year. And the company wanted to understand how can we know beforehand which one will survive, because just 5% of product launches survive. After 2 years, most of them are gone. Which is interesting because big companies are launching it, investing lots of market research in it, and still just 5% survive. And they took all the data and used statistical modeling with it. And the explanation power, R squared, 0. Couldn't be explained. Okay, it's logical because obviously the other companies who launch all the products can't explain it either, right? So we used Causal AI and could explain, could predict beforehand a successful launch by 81% accuracy. And this sounds to be a miracle, but I will explain you now what we found, and you will see that's logical. Why didn't you thought about it beforehand? So what did we do? We used a huge data set, 200 variables, spanning every information about distribution rate, repurchasing power, how is it perceived, how does the packaging look like, what kind of brand is it, how is the pricing, and so forth, and even the ingredients. But the key of the finding is this is a multiplier. What it means is that the key drivers, they do not add up, they multiply. So in short, you only will sell a product if it's in the shelf. If it's not in the shelf, you don't sell it. Yeah, it's logical, right? But if it's on the shelf, but it's not good, it tastes bad, people will not rebuy it, right? So the best physical availability is not useful if it doesn't taste good. But if it tastes good and it's in the shelf, but your maintainability, basically you don't recognize the product on the shelf, people will not rebuy it again, right? So it will fail again. But even if all this is good, but the product makes a bad impression, it just looks crappy, it will not be bought in the first place. Or if everything is great, but the pricing is off balance, also the demand is very low. So in conventional statistics, we have this kind of regression approach where you have with different factors and you add up the approach, or the impact. But the impact does not add up, it multiplies. Yeah? There are conditions that you need to be all met at the same time. So after the fact, pretty logical. Yeah? But with Causal AI, it found it itself without me telling him there are conditional formulas in there. Because of that, it can find this formula in the data by itself. It was able to predict success way better than ever before. Well, not to me, I'm Frank Buckler, I'm founder of Success Drivers. I'm selling these t-shirts, so I'm doing AI since 30 years now. Started when studying, did prediction systems in there, and then did my PhD on developing causal machine learning technologies. Published already neural networks 20 years ago, and finally found Success Drivers. We are a service agency helping companies to draw causal insights from marketing data and insights and research data. And we have also a causal AI software, neutral.com. And we work for many reputed clients around the world. Cool. Why causal AI? Where's the use of it? Let's look into why we should use it and where the applications are. This is, I love metaphors, as you can see. That's a metaphor for conventional statistics. Conventional statistics modeling, I mean, it's decades old, and it's many smart people developed smart stuff, and it is working. It's really like a Formula One car. It's super precise. It's really good stuff. But a Formula One car just drives on the Formula One circuit. That are the assumptions you need to put in to make it work. So the conventional statistics relies on you to know something about the business or the data so that the algorithm can be fantastic. But my experience in marketing practice is this is not reality. Reality is we have a foggy ground. We don't know if it's sandy, if it's a Formula One circuit. We don't know. It's basically impractical. Practical is to have a Land Rover and just go over and drive over. You are not so fast, but you arrive at your goal. Because of this property of conventional statistical modeling, AI is evolving. Yeah? This is why AI is so powerful, because it now does not rely on strong assumptions anymore. But as you see, there are problems too with AI. It drifts. One key issue with AI is model drift, or some data science call it data drift. What it is basically you build your model on your data, you maybe leave out test data, whatever, it works, it's great. And then you take this model and apply it, and sooner or later it fades out, it doesn't work anymore. And nobody knows why. Yeah? Sooner or later the models drift, and nobody knows why it doesn't work anymore. What data science then do is to just takes the latest data and rerun it, but it doesn't solve the problem. Yeah? Another issue is that AI can create some unfounded discrimination, and that finally you do your AI, you do maybe explainable AI on top of it, but explainable AI is just making you having a look in the AI, but still if the AI is drifting, yeah, you will find something which will not work anymore, So that's what you see. And all those three problems are reasoned by one cause: the lack of causality. This is an example. Let me explain. Recently, I have two boys, 8 and 11, and they came to me, hey, Dad, let's play soccer outside. I looked outside the terrace. The terrace was wet. I said, it's raining. We cannot play. They said, no, it's not raining. Yeah. And then I looked into the sky, and it was free sky. So what I did is I used an indicator, the wet ground, to predict that it is raining, but this is not a cause. Yeah, I should rather have looked into the sky if there are cloudy rain clouds there, which is the cause. But if you are not using causal information like the wet ground, your model can be wrong. Yeah, that's what AI is doing. It just uses everything just to predict, and got the risk to be wrong. And we all know this saying, causality, correlation is not causation, and these funny statistics here, divorce rate correlates with margarine consumption. But while this is funny, different examples are reality. Actually, it's not funny anymore. Some examples here. We did explain why people buy lottery tickets. And when you look at the correlation, when you look at the data business leaders look at, is typically these kind of things. And they see, hey, all the people buy lottery tickets. Yeah, and if you know all the people buy lottery tickets, it's obviously that's our target group, right? Because why shouldn't all the people buy lottery tickets? They are obviously like it more, right? That's where the industry puts the whole marketing strategy in this. Okay, all the people are our people. We need to sell to them. But if you take all a holistic data set, you find that the opposite is true. This is a fact, but it does not represent the causal relationships behind that. The causal relationship is that what drives ticket sales is ritualization of buying lottery tickets and the experience of winning. And both happens over time, like the age. Yeah? The older you are, the more likely is that you have ritualized it and you have experienced winning. Because of that, you are buying it, not because you are old. So the marketing strategy is the opposite. Grab the young people, make them ritualize the whole product, and make them experience it. Don't do these jackpot things. Yeah, the industry do jackpots. Yeah, because when they do a jackpot, lots of people buy the ticket. But this is a short-term correlation. It's like Black Friday. What you are destroying is a ritualization. Yeah? And you lose what your success drivers in the industry is. So understanding why people buy is totally changing your marketing strategy. And this is not an exception. Actually, in most industries we look at, we see that there are a lot of myths around why their industry work. For instance, we looked at NGOs, yeah, why people are donating. And again, the industry believes old people are a target group. Old people donate because, I don't know, no kids around anymore, whatever. But if you take a holistic data set, you find this is not true. Age is just a spurious correlation. The key driver is if someone has saved some money, yeah, then they are open to donate. And of course, the older you are, the more money you have saved. Yeah? It's correlating, but it's not the cause. Yeah? It's not that if I own 10 million, I'm donating 10 times more, whatever. It's really there's a nonlinear thing. Nonlinear, you just need, if you have some savings, you are open to donate. Yeah? If you have no savings, there is no room for donation. Yeah, and here you can, in this, what this causal modeling typically is a holistic view on the customer. Yeah? It doesn't look at things you want to know. It really looks at why people are choosing a brand or donating. And then you need to consider all the person or the situation, the demographics, everything plays into it. And you learn how to position your brand properly and so forth. Other example is improving creatives. We did some big studies in 2017 already, where we did lots of different copy tests, but also about TV spots, but also then categorized what the TV spot actually has, what's in there, 200 variables. Is there a celebrity in there? What kind of storytelling is it, and so forth. Yeah, it all floated into a causal model explaining what are the triggers, what are the emotional settings that work, why is creating a spot a purchase intention. And I was reminded to this as John told me that Kantar is now offering this Kantar Link AI. What Kantar Link AI is doing is basically taking also all the copy tests and also categorizing what's in there, but automatically with AI, yeah? But with a different analytical setup. It just does it to predict the outcome. So it does it in order to avoid running the market research again. Yeah? So that's why it's so popular for clients. They can basically predict what's the outcome of the copy test, right? But if you would do that with causal AI, you could then understand what are the key drivers to improve, to make a better commercial. It's obviously, I think the mindset is not there that people are demanding it, but sooner or later this will be the case, I believe. Two examples in terms of Gen AI. Yeah, so Gen AI is the peak of the hype, but what we found is that causal AI is perfectly complementing Gen AI, because with generative AI you can create fantastic text, fantastic pictures, videos even, but how do you evaluate that it is good? Okay, you can run a test again, right? But there are unlimited ways of producing content with Gen AI. You cannot do thousands of tests, right? A better way would be rather to first find out what are the key drivers that make the ad successful, and then prompt the AI so it can create a powerful content in the first place. That's what we tested here for Samsung. Basically did brand archetypes, market research with purchase intention question, run it through Causal AI and found that certain brand archetypes, especially here the Explorer, are the key driver to evoke willingness to buy the brand. And this was basically used to do a very specific prompt, create an adventurous picture with a Samsung phone, and we created a slogan with a similar prompting. This is German. This is freedom to go forward. And there were no creatives involved. It's just researchers did this stuff. And it performed fantastic in a test later. It was tested in context. So in real feeds, it was tested, and it created a market share uplift of 18%. This without testing hundreds of different examples. Another example, we used text generative AI to create a better subject lines for direct mails. Yeah? So we started, actually this was our own internal thing. Yeah? We started with, we asked experts, and we tried that and found out that what experts find most annoying has best performance. Yeah. So that's why we then head off and tried very, very strange stuff. So lots of different subject lines. And we got some, this all were the winner kind of, right? But this was basically the input for the learning set. So we have lots of different subject lines tested and have the opening rates, right? And this data set went into Causal AI, where Causal AI found that the key component of a subject line to be opened is dominance. Yeah, so the context, you can have a subject line and describe it with certain base associations like dominance, balance, whatever. There are certain base associations, and that's what we did, and these were the drivers. And we found that a dominance felt subject lines creates openness. And then we basically asked, hey, create a dominant subject line. Straight to the point. Was opened 54%. So again, with Causal AI, you can find out how to create better content. This is how it merges. So to round up where to apply Causal AI in marketing, first off in strategy, yeah, why people buy it, who buys it, you can find the proper target groups for your product. You can optimize products, yeah. You can use it, for instance, as an alternative to conjoined for customer experience drivers, even for marketing mix modeling. You can improve your content creation by understanding how to prompt better. And of course, it's also useful for direct marketing for every person in your database to know, will you churn, will you accept a certain treatment. Cool. So, what is it now? How does it work? So first off, what's AI? So that's now the difference between statistical modeling and AI visualized. That's statistical modeling. It's a fixed formula, and you find out the parameters, the steepness, and fit it into the data. That's modeling, right? And AI is a formula that you find by fitting the data. You don't look for parameters, you look for a new formula that explains data better. Yeah, that's adaptive, that's a learning approach of AI, of any AI. Okay? But now, as you see, we need to improve that because AI has this model drift, discrimination, and wrong insights problem. And what we need to solve are, at core, 4 issues. First off, multicollinearity. Yeah, drivers correlate with each other. Confounder problem, the direction, what drives, what is the outcome, the effect or the cause, and indirect effects. We'll talk about each of that now in more detail. Yeah, that's kind of a multicollinearity issue, yeah. So you have different, oftentimes your drivers correlate, right? If you have service quality and friendliness, it correlates, but what is causing the outcome? That's a prominent example here for loan prediction, yeah? So where you have, for instance, your salary, ethnicity, zip code, everything correlates because they are interrelations, yeah? And if you throw those blue variables into an AI, it will use them all because the only goal of the AI is to then predict this one. It doesn't care if ethnicity is not the direct cause. It cares. It's an algorithm, right? And the learning mechanism is only implemented to best predict this at using the data. And with causal AI, you do it differently. You include the intention, the goal, that it should also be causal. And for that, you need to decide if it's all correlating, which one do I really need? Yeah. How much do I lose if I skip one, yeah? 1 or 2. I lose a little bit, but not too much. So I can, yeah, that's what the algorithm would think if it would be a human. It can decide, hey, with salary, I only use salary. I'm losing just a few points of explanation, but it is therefore I'm choosing the right course. Yeah, that's handling this. For handling this multicollinearity, there are different methods around there. Mostly used so-called double machine learning. We use also another methodology which is called automatic relevance detection. It is basically implements the search for the cause in the learning algorithm. Second issue is the confounder. If you are missing important information in an important cause in your data, it can happen that what you found is totally wrong. Example. It's a real example where we had clients from an insurance company and they are likely to recommend an NPS answer, right? And we looked then in the future, yeah, we had that over years, and we saw, hey, when did they churn? And so had basically can say, hey, this person had a high churn probability or a low churn probability. And if you, in this churn probability and likely to recommend correlate positively, the more likely to recommend, the higher the churn risk. Doesn't sound right? But it's a fact, right? It's a fact. but fact doesn't tell you something about the truth. Facts are correlations, are singular things, but the truth, the relationship between action and outcomes is something which is invisible. You need causal modeling to find that out. And the reason for this is a customer segment. There are certain customer segments which have higher standards. Yeah, they don't praise too early. So they per se they have a lower NPS answer. But actually they are more loyal. Yeah, they are simply a different affluent customer segment, which just have a different answering pattern. Yeah, and if you have this third dimension, and you put here a regression into it, yeah, you have a positive steepness into this segment dimension, but the likelihood to recommend this steepness is negative. Yeah, so of course, the higher the likelihood to recommend, the lower the churn probability. This is why we want to build holistic models. We want to have models which not just have drivers of your brand, it also has the demographics or the situation the customer is in, or maybe their value systems. You say, oh, but how can I know? Yeah. That's a problem. That's our task, to build holistic data set, and we will never have a perfect data set. But what's the alternative? What is the alternative? We are here to create insights that drive better decisions. The truth will be something. It's a polar star where we're heading to, but there will always be challenges. The fourth topic was causal direction. Yeah, is satisfaction driving loyalty, or is loyalty driving satisfaction? Yeah, so you can assume it, or you can, if you don't know, there are some algorithms which test for it. Most famous algorithm is a PC algorithm. It tries to triangulate looking at correlations. So if you have these three variables, A and C is correlating, B and C is correlating, but A and B is not correlating, from this situation, you can infer that A and B must cause C and not the other way around, because if the errors, red errors, would be the other way around, it would cause A and B to correlate. And based on these patterns, the algorithm do some assessment on what the true causal directions are. Right, and the issue is it doesn't work very well if you have too many variables. So that's why there are other algorithms like additive noise modeling. This here, yeah, is X on Y, and this is the same data. It's the same data, just flipped around. Yeah. And if you do a regression, it has the same explanation power. So you cannot understand causal directions by explanation power. You can only, here you can try to use an assumption. The assumption would be that the noise you have is independent from your cause. If your noise is independent from your cause, then this must be the right causal direction and not this. That's what additive noise modeling algorithms are trying to look at. Indirect effects, if you do an advertising and then look at sales, right? So like a marketing mix modeling. Marketing mix modeling looks at direct effects, but the main effect is actually that the TV drives brand strengths and will drive a few days, months later, the sales. If you don't have this indirect effect in your model, you are missing most of the impact, which often happens actually in marketing mix modeling. So if you sit in your room, you're not just hearing the direct sound, you're also hearing the reflections. That's what you want to know. You want to know what will happen if I do something. There will be direct and indirect effects. And that's why causal modeling is not an input-output modeling. It's a causal network, right? Input-output is like a regression formula, drivers, outcomes. But most of the time you have indirect effects, moderators, and stuff like that. And consider that to consider the proper impacts. And finally, when we do all this modeling, we want to do it in an AI way, not fitting the rectangular into the round. We want to first learn, oh, is it round or not? Quick example, this was for pharmaceutical sales, So kind of a marketing mix modeling where we had all these different things they did and the prescription numbers. And what causal AI then found is something nobody has thought about, that product samples work, providing product samples, but if you provide too many, it will harm sales. And if you think about it again, it's very logical. If the doctor has too much samples, he will not prescribe anymore. He will just give the samples to the patients, right? That's what I mean. Explorative is pretty useful because you learn something you haven't thought about. So causal AI, what is it? This is statistic modeling. Finds parameters to the formula. AI finds the formula. Deep learning just works with more variables, and Gen AI is basically pre-trained big deep learning system. But that's basically AI. And causal AI is actually a new dimension. It tries to filter, tries to provide a filter system so that the model fits better to the reality. It's like a spirit filter machine. If you don't have a filter, you have methanol. You get out of methanol, it's pretty poisoning. You need to filter these shelves of the crop to avoid that. And that's basically what causal AI is doing. It is a kind of a filtration system, right? So how to get started? You not just need a different software, you need a different mindset and a different process. First off, mindset. I go quickly through that, but just to inspire a bit. Statistical mindset is all you need is enough data. Know the meaning behind the data is important in the causal mindset. We reduce the model to become significant is a mindset of a modeling approach which is confirmative. You have hypothesis and then you eliminate everything which is not significant. But actually that is neither useful nor relevant. To understand what drives causal outcomes, you need large models, and significance is just a measure whether or not something fits to your hypothesis. But if you reduce your model, it's more likely that the whole model is wrong, although it's super significant. That's a totally different mindset you need to use. Same thing with dimension reduction. Again, we don't just do input-output variables. Each variable can be input and output dependent or independent. We not just maximize the fit of the model, I want to use maximize the evidence. That's a term for Bayesian modeling. And we not just test profound hypotheses. That's the conventional approach to say we have hypothesis and we test that. That's fair to do, but actually, if you look at the reality, it's not very useful because we don't have those profound hypotheses in reality. Instead, we use weak hypotheses together to build a holistic data set. And then we can also use hypotheses to restrict the model if we really are pretty sure about our hypothesis. So how we work is basically we have a kind of a bucket system. Hey, what are our outcomes? What could be the mediators like brand? What does it drive? Maybe brand perception. What does this drive? Maybe touch point contexts. Demographics, which situation is the buyer in, and so forth. So these are different buckets. Yeah, we start from scratch and then get the domain expert and basically understand what should we measure. Yeah? So the process is basically use expert knowledge to collect data, and also we can use expert knowledge to assume causal directions. So especially in marketing, we know that age is not driven by brand. So age will stay the age, right? Or the brand is driven by the items and not the other way around. So there are some things we can assume which make the model better. So with that, we use spatial AI, which can handle multicollinearity. It models network. It's network input-output effect. And at the end, we do some test algorithms to test for confounders, for causal directions. And sometimes we need to change the model and run it again. Yeah, we do that with causal AI software. On the left, you see different software packages. Most famous Causal Lens here from London. They are funded with 50 million. They really push the domain, but they are open source systems. But we at Success Drivers, we launched this Newsrule, which is doing a lot of things different than the conventional Causal AI packages. And we believe it's best designed for marketing purposes. And it's available online. So in a nutshell, statistical modeling is fantastic if you know the ground. But because we don't know the ground, and most of the time AI is pretty useful, AI has some issues, and with causal AI we can filter the outcomes so that the recommendations we draw from this modeling will work better and will drive meaningful strategic decisions. Yeah, so hopefully companies are starving. Let's filtrate the data with causal AI. Hope you are with me on the journey now. I've, for every one of you, a book in the other room. You can pick one, and for all those things, we have more case studies explained in more detail in this book. And I thank you for your attention, and I'm happy to engage with you. Just shoot me an email at buckler@successdrivers.com. Thank you.